Hey Bobcats, it's Mr. Peterson. Today we're going to go a little bit further into complex numbers by learning how to perform operations on them. First of all, you'll want to write down this. We saw a picture of this the other day. This is the complex plane in which we have a real axis and an imaginary axis. And it's important to note that on the imaginary axis, our unit that we're counting by is I, which hopefully you recall from the previous lessons, I is the same thing as the square root of -1. So go ahead and write down that definition and probably make a copy of that plane, because we'll be using it here in the next couple problems. All right, so first of all, graphing complex numbers. So a complex number, as you'll recall, has a real part, which is this part over here, and then it has an imaginary part, which would be this part over here. So the real part, that's how far we would go on the real axis. The imaginary part, that's what we do on the imaginary axis. So as you can kind of see here, for example, A, for -3 plus 0i, we would go to the left 3 and then up 0i. So there we have the point for A. All right, let's look at B, -3i. So you'll notice, of course, this one does not have a real component. So it's kind of like 0 plus -3i. So in other words, we're not going to go left or right on the real axis. But we will go, since it's -3, we will go down 3i. So there's point B. On, erase that, on example C, we have a real part and an imaginary part, so we would go 4, so that's positive 4, so we go right 4, and then we would go up 3, because it's a positive 3i. So there we wind up with point C. And then lastly, point D, -2 plus 4i. -2 means we would go left 2 on the real axis, and then 4i we would go up 4 on the imaginary axis. So there's our fourth point, D. Why don't you guys try this one? And this one. Okay, first of all, we also need to remember that absolute value is how far a number is from 0 on the number line. And we can also attach an absolute value to a complex number. And the absolute value of a complex number is tied into its distance from the origin. How far is it from the origin? And it kind of has its roots in the Pythagorean theorem, or in other words, the distance formula. To find out how far something is from the origin, we're going to need to find out first how far is it horizontally from the origin, and then how far is it vertically from the origin. And then by taking the square root of it, we can then find out how far it is from the origin. So this is how we're going to try to find absolute value with complex numbers. So you might want to write that into your notes. So let's try this one. So this is telling me that I have to go left 9, and then it might be helpful to just rewrite this, that this is -9 plus 1i, just to be absolutely clear. Normally you wouldn't write the 1, but just to be absolutely clear. So we're going to have to go left 9, so -9, but then we'll have to go up 1 unit. So we need to find out how far is it from here to here. So again, it's like a Pythagorean theorem or a distance formula problem. We would do -9 squared plus 1 squared. -9 squared is 81. 1 squared is 1. But then we need to take the square root of everything. So this is really the square root of 82. Which that is as simple as it gets. That's its simplest form. Okay, for the absolute value of 6. Now I know you're just saying, Mr. Peterson, it's just 6. Well, let's think about it in context of this problem. Its real component is 6, but then it has an imaginary component of 0. Just to be 100% clear there. So if we're thinking about this in terms of graphing, we need to go to the right 6 and then up 0. So in other words, we need to figure out how far is 6 from the origin, and it's 6. Circle that one. And then lastly, negative 4i. Again, on this case, we don't have a real component, so it's like 0 plus a negative 4i. So what that means, oh, wrong symbols. What that means is we need to go to the left or right 0, but then we need to go down negative 4i units. So in other words, and remember our units when we go this far are counting by i's, so we went down 4 units. So our absolute value is 4. Our absolute value is 4. All right, why don't you guys try this one, and this one, and this one. All right, we can also add and subtract with complex numbers, and it's important to note that, just review that complex numbers also have additive inverses. So the additive inverse of a plus bi is the opposite of a plus bi, or negative a plus negative bi. All right, so to add or subtract, we're gonna just add or subtract normally. All the properties that we know still apply: distributive property, commutative property, associative property. They all still apply to complex numbers. So we can use those ideas here. Combining like terms also. All right, so really this is going to be a, this is going to be a negative 2 plus a 4i, and then it's a positive here, so we'll just say plus 3. And then I'm going to change it to plus a negative 11i, just because I always like to rewrite subtraction as addition. So now we would want to combine our like terms. Here are our numbers, our real parts. Here are our imaginary parts. So when we combine our real parts, negative 2 plus 3, that's going to be a positive 1. And then a 4i and a negative 11i, that would be plus a negative 7i, or if you want to clean that up a little bit, 1 minus 7i. All right. Over here we have 4 minus I minus the quantity of 5 plus 8i. And here we definitely want to change this to plus a negative so that we can distribute that negative correctly. So I'm going to just carry this down. This is going to be 4 minus or plus a negative I. And then let's distribute that negative. So plus a negative 5 and then plus a negative 8i. All right, so let's go ahead and combine our like terms. We have, here's our real components, here's our imaginary components. Let's get those added. 4 and a negative 5, that would be a negative 1. And then a negative I and a negative 8i, that would be a negative 9. So plus negative 9i. But in simplest terms, or in just a little bit cleaned up form, that would be negative 1 minus 9i. All right, next up, I'm going to erase that and pull this up. 6 minus 2i plus negative 6 plus 2i. So again, we're adding here, so we need to distribute a negative. So 6 minus 2i plus negative 6 plus 2i. Let's combine our like terms. Here are our real components. Here are our imaginary components. And again, it might be helpful to rewrite this as plus a negative. All right, so our 6 and our negative 6 will cancel out, giving me 0. And then we have a negative 2i and a positive 2i, which that will also cancel out and give me 0. So my answer here is 0. You can see that those are the conjugates, the additive inverses there. So let's look at one more here. 10 plus 3i, and then the minus the quantity of 10 minus 4i. So we definitely, again, want to change that to add a negative so we can distribute that negative 1 correctly. So let me go back to white. 10 plus 3i, and then plus a negative 10, and then plus 4i, positive 4i. Alright, so again, our like terms, that would be the 10s and the negative 10, and then our imaginary parts would be the 3 and the 4i. Alright, so if we combine them, the 10 and the negative 10 gives me a 0, and then plus the positive 3i and the positive 4i gives me a 7i. So in a cleaned up form, that would be just 7i as our final answer. Alright, so why don't you guys try this one, and this one, and this one, and we'll see you in class today.